Hello everyone, welcome to today's session on Flutter to develop apps for Android, iOS and web. Before we start the session, I think we are going to wait for more people to join. Let us give it 5 to 10 minutes and then we start. This session is going to be useful for beginners as well because we are going to start from installation. Hello Anand, just saw your question on the live chat on YouTube. So you're asking about how to set up emulator on VS Code or in Ubuntu. We will be discussing about installation instructions when we start the session. Um, so when we start the session, we will go through installation process and it will be very similar for Windows, Mac and Linux. I'm not exactly sure Ubuntu OS will be supported. Um, Hello everyone. We are waiting for a few more people to join. We just give it a few more minutes and we kick off our session. Hello all. We will start the session in another 2 minutes. Just waiting for more people to join. Hello everyone. I think we are ready to start the session. Okay, welcome to today's session on Flutter. We are going to discuss about how to develop apps for Android, iOS, and web using Flutter. Okay, so about myself, my name is Naresh Idiga. I'm a senior Android consultant and founder at Roboto Systems. I have been working on software development for more than 14 years. I worked for clients ranging from startups to big companies like Motorola and HTC. And I spent more than 10 years alone into mobile apps development. So, so today I want to take you through one of the most promising frameworks for app development. And Flutter is developed by Google to build mobile, web, and even desktop apps. So that is all good. But why should we learn Flutter? What makes it different from other frameworks? So the main reason is that we can build an app with single code base that runs on all Android devices, all iPhones, Windows, Mac, and even Linux desktops, all with a single code. So never before in technology we had such a framework that makes it so easy to run a single code and to be able to see the apps running on all the operating systems. And not only that, another main reason why we should care about Flutter is Flutter comes with its own UI rendering engine, which means that Flutter can draw anything on any OS without depending on the platform provided views for drawing the UI. This is very similar to how many game engines work, like Unity. Uh, but we never had such a good framework like Flutter because it not only comes with the inbuilt UI rendering engine, it provides us a lot of ready-made toolkit in the form of widgets to develop the apps quickly. So we will see more about that. And and another thing to note is that Google is developing its future OS called Fuchsia, and Flutter is officially the UI development tool for Fuchsia. So if we start working on Flutter, we can have apps running on Fuchsia as well. And since Flutter has its own UI rendering engine, Flutter really has capability to support any future OS other than Fuchsia. Okay, so that makes it a very rare tool, and I'm very glad that we have such a nice framework available now, and we are really ready to hit the road building apps for all platforms without having that struggle of maintaining code base for single platform, each and individual platforms. In many companies, they have teams, one for each OS platform, Android team, iOS team, web team, whatnot. So it's a big cost wise it's huge for companies, and it's very difficult to get the user experience uniform across all the platforms when you have the code distributed on each platforms. But with Flutter, we are going to fix that problem. Okay, so what we need to develop apps on Flutter. So some of the things we need are obviously Flutter. We need to download the Flutter SDK, and then we need to set up path to Flutter bin directory in the SDK folder, which we need to execute some useful Flutter commands. Then we need a powerful IDE like Android Studio or Visual Studio. You can actually use any code editor, but it is better to use a powerful IDE like Android Studio. And those working on a Mac need to install Xcode if you want to test on iOS simulator, build iOS apps, and publish on App Store. And finally, we need Android Emulator. And another option is we can test on real devices as well. But for today's session, we are going to use Android Emulator and iOS Simulator. Okay, so before I start taking you through the installation process with more brief instructions, I want to give you a glimpse of what you are going to learn by the end of this session. So by the end of this session, we are going to have a look at you are going to understand how to build an app that is shown on this emulator, and understand how you can also build it. Okay, so this is the simple app that you will be able to build by the end of this session. Okay, you have a grid showing a gallery of various places, and you click on each item, it will open up a detailed view displaying all the details. Okay, so let's get back to our installation instructions. So to start installing the Flutter SDK, go to Flutter website, flutter.dev, and hit on docs, and then just simply go to get started. Here you have options to select Windows, Mac OS, and Linux based on which machine you are working on. Say Windows, if you are working on Windows, go to the Get the Flutter SDK and click on download this zip file. Okay, once you download this zip file, extract it, put it in C drive at the top level, somewhere like C drive /software /Flutter SDK, and then in that SDK you will find a bin directory. Okay, all you need to do is open your environment variables. If you just simply run the command env, and it will open the environment variables, and find the variable path in that. And once you find the variable path, append flutter /bin to it. I mean the full path where it is present on your C drive. Okay, so that's on Windows, and once you set the path, you can test if it is working by opening a console and test the command flutter doctor, and it will start complaining that you don't have Android Studio or you don't have Xcode. I mean such. The Flutter Docker is like a diagnostic command. It will tell you what's missing from the dependencies we need to have. Okay. So let's go back to Mac OS. So it's pretty much similar process. So do not worry about elaborate instructions here. Simply download the SDK zip file, unzip it, and put it on your current user directory, and set the path using. You can set this path in your in your current user directory and bash profile file. Open your bash profile file and set the path to Flutter SDK. Okay, so once you have that, we have the Flutter SDK, but we need to be able to write the code. So we should go and download Android Studio or Visual Studio. So for that, you can check here and install Android Studio section here at the right side. Simply click on that and go to Android Studio. Okay, and simply click on this. You will be able to download Android Studio. There is a preview of Android Studio here. Okay, simply download Android Studio. And if you are on Mac, go to App Store and search for Xcode and download the Xcode. Okay. Once you download Android Studio, open Android Studio and click on configure at the when you open Android Studio, it will show you an option to open configure, and from which you can open preferences. Okay. Actually, the first time you open Android Studio, it will ask you to download a default SDK and default build tools for you to get running. So first go through that. Just download whatever Android Studio tells you. Simply follow the default options. So once you have downloaded the SDK and tools, and then open the preferences in Android Studio. And in preferences, go to plugins, and in plugins, go to marketplace and search for Flutter, and you should be able to find a Flutter plugin here. Since I have already installed it, it shows as installed. For you download Flutter, it will also download you a Dart language plugin. Right. So Dart is the official language in which we will be writing apps in Flutter. So but nothing to worry about Dart at all, because Dart has a very familiar syntax that we have already worked with. Like if you worked on C++, C++, Java, okay, it is very similar in syntax, and we won't be actually heavily relying on language features, but we will be more relying on the Flutter concepts, Flutter framework widgets, rather than the language features. Okay, so if you are new to Flutter, and if you think Dart is a language that you don't know, but all I have to say is Dart is a really simple language. And easy to understand. Okay, so install the plugin, restart Android Studio, and then you will have support for Flutter inside Android Studio. Okay, so once you have that, you can start a new Flutter project. Click on new Flutter project, select Flutter application, and just choose a default name or give it whatever name you want. Okay, then simply choose finish. The first time when you create Android Studio will take time to set up everything. And in the meantime, just simply select new window if you have multiple windows open. Okay, so this is a default application that Flutter provides us with. Okay, so far we have downloaded Flutter SDK, we have set up the path to bin directory, and we have downloaded and installed Android Studio or Visual Studio if you prefer Visual Studio. Same process. Just simply download Visual Studio and install it. and you need to install Xcode as well on Mac. And once you have installed Xcode, open Xcode at least once, and it will ask you to agree to licenses and do that. So once you agree to those licenses and you no longer need Xcode, you can simply come to command line and search for simulator. Once you have downloaded Xcode, this will be available. This is the iOS simulator, and hit on simulator. It will start up an iOS simulator. Okay, so we have got iOS simulator, Xcode, Android Studio, everything. All we need is Android emulator. For Android emulator, inside the Android Studio, go to Tools, click on AVD Manager. Once you click on AVD Manager, it will ask you to create a new virtual device. Okay, so you can create a new virtual device. Like choose an option from here. Okay, then simply select one of the images like Pixel 3 or Nexus 6, whichever you prefer, and just click next. And it choose any somewhat recent Android OS like Android Oreo or Android Q, and click next and click on finish, and it will create an AVD for you. Okay, once it creates the AVD, it will show you it here, and you can simply tap on the start button. Okay, and it will launch the emulator. Since I have already opened a Pixel 3 emulator, I'm not going to do that. Okay, let us close this one. Okay, so now we got our Android emulator and our iOS simulator, and by default to test on web, we have support to run it on Chrome browser. So once we select Chrome browser and run our app, it will open up Chrome browser and start running the app. Okay, so we have a default app created here which says my app, and it is building something called a material app with a title and some theme and some home page. Okay, let us look into how it's gonna look on each of these devices, the emulator and the simulator as well. So this is how it looks on Chrome. So this is the default app. This is a simple counter application. We have a button at the bottom, and you have a message. As you tap on this button, it will increment. Okay, so this is the default app that comes with the Flutter plugin. Okay, so now let us also run this on Android as well. Select the Android emulator here and click on run. And also select iOS, click on run. You can observe that it has opened 3 tabs here, and it is trying to run on each of the devices. The very first time you run, it is gonna take a while because there is a build system called Gradle. Gradle is going to execute of the very first time, so it is gonna fetch a lot of files, download for it for the build system. So it's going to take a while for the first time when you start running on Android emulator as well as iOS simulator. Okay, let's just give it some time. And in the meantime, we can look at what's going on here. So here we have our test app code, and we have a lot of directories here, but let's take the most useful ones. The most useful ones is actually this lib directory. Other directories, we do not worry about them. What Flutter does is it creates one directory for each platform. As you can see, Android, iOS, one for iOS, one for web. So these are each one for each OS platform. We are not going to touch any files in those directories, okay, usually. So let us start with what's inside the lib directory. So lib directory is where all our code for the app is present, and there is only one file called main, which we have opened up here. So this main file has the main entry point with the main method, like our traditional way. We simply have a main method that is running, that is calling another method called run app. Okay, so this is all the starting point, and from here the run app will execute the root widget. So in Flutter, everything we see on the screen is a widget, and even those things that we don't see on a screen are also widgets. So uh, in, and Flutter provides us with a lot of inbuilt widgets, and they are of just two types: stateless widgets and stateful widgets. So the difference between stateless and stateful widgets is really simple. When we have to update UI, so you have a text view here that is going to update when you press this button. So in such cases, when we are updating UI on user interaction, or maybe there is some data coming from the server and you need to update the UI, you have to use stateful widget so that you can track the state. So in here too, we can track the counter as a state, because that is the only thing that is changing. Okay, so that is and for the discussion today, we are not going to go more about stateful widgets. We are going to simply look at stateless widgets. But to give an idea, this app simply maintains a state for its widget here, as shown on the home screen, and it simply maintains this counter variable that is tracking the display value here. Okay, and for now, do not worry about this code, because I'm going to take you a simple example than this one, so that you will have a better understanding. Okay, now we have it running on our Android emulator, and of course on web and on iOS as well. So now we have our sample program running on 3 platforms. Okay, let's resize the web thing. Okay, so right, so here we go. So we have Android, iOS, and web, 3 apps, each on different platform. Okay, running with single code, and the whole code that is running is from this single file. Okay, now Flutter provides a feature called hot reload, and which means once you have the apps up and running, if you change something, let us say we change this simple text here, let's change this, like just simply change it, like we push button this many times, something like that, and you can go to run and simply do Flutter hot reload. And you can also see there is a command slash as a keyboard shortcut. You can use that, or you can also use command S button, which we will usually use for saving something, command save. So we can save, you have a couple of options to trigger a Flutter hot reload. Okay, and it has actually updated on iOS, because we have run only on a single device. So if you can see here, it has updated the text that we have pushed. Okay, but what if you want to show this update on all the 3 of them? So you can see Chrome and our Android emulator are not up to date. You can do that as well. You can simply go to run and do a Flutter hot reload on all devices, and that will change immediately on all the 3 devices. Okay, Okay, that is about Flutter hot reload. But Flutter hot reload will not work for in some situations like global state variables. If you have changed something in the app state itself, so any state related variables. For that, you have to do Flutter hot restart. So this is simply another option here. You can see we can do Flutter hot restart. Okay. Flutter hot reload will work for most of the cases, even if you have changed, assets like images. But for those cases, those exceptions where Flutter hot reload cannot work, you can use hot restart. And sometimes you have to end the session. So this red button is to end all the processes and start fresh. Okay. Okay, so now you know how to run a simple program on all the three platforms. Let us understand about the user interaction and what we can do to provide a great user experience in Flutter. Okay, so we have seen that we have used so many apps in our everyday life, and we all know how addicted we are to those apps, and because they come with a beautiful UI and very useful, and it solves a very essential problem for you. Okay, and the way a user primarily interacts with an app is through the user interface, right? So if you have seen apps, you would have seen a list or a grid, a set of chart conversations. So what we usually show to the user is a lot of images, text, and icons, you know, and beautiful animations, and you build the brain of the app, and you fill the app with the data, and then you are ready to go. So Flutter makes it really easy to develop the UI. Flutter, as I discussed before, like, so everything in Flutter is a widget, and layout widgets are the ones we will be using to develop the user interface. So here are some examples. This is a grid view, this is a list view, and this is a card view. Okay, and Flutter heavily relies on material design. Well, you can develop user interface whatever way you like. Flutter provides you with all the options to do any customization as you like, but it makes it faster if you are going to follow material design principles. And those of you who are not aware of material design, just a quick thing about it. Material design is a set of design principles provided by Google. You can check material design website. There is a lot of information about how to design beautiful apps and provide a great user experience. Okay. So we are going to implement widgets to show to the user, but there are two types of layout widgets: single child layout widgets and multi-child layout widget. So in single child layout, these are the commonly used widgets: container, center, and padding. Okay, if you have worked before with any of the other platforms, you might have seen that padding just as a property, center just as a property, but in Flutter, this is something different. Even each property is itself is a widget, but not to worry, we don't have to use these widgets every time. If you want to have multiple properties in a single widget, we have container that solves the problem. Okay, and similarly we have multi-child layouts called column, row, and list view and grid view, and these are very useful when you need to combine multiple UI components. Okay, we will understand more as we go through the through demos. So as I just said, a container has, you can provide padding inside the container. So this red marks here, sorry, uh, these red arrows here are padding. This rectangular box is the child of a container widget, because this is a single child widget. That means this container widget can contain another child widget, and that child will occupy this blue rectangular box. And if you put the same child inside a center widget is simply going to take all the available space and put our child widget at the center. Okay. And similarly, padding widget, it simply provides padding. You can provide padding at only one corner, like you can provide padding at the top or to the left, to the right, or to the bottom, or you can just give it at all in all directions. Okay. Similarly, align, you can have the child widget, positioning. You can control the positioning of the child widget within the space given. So this is the space you have, and you can have the child widget at the left bottom corner here. Or you can have it at the center. You can have it at the bottom right corner or the top left corner. So you have more control over the positioning. Whereas multi-child layout widgets, you can group multiple UI components inside each of them. And when we say a child, or we are simply saying another widget. So in Flutter, to build UI, you are basically either going to group multiple child widgets inside a multi-child layout, and also at the same time use a single child layout widget and just simply put a single child. And this is all depending upon your prototype. Okay, your designer gives you a prototype on how your app screen should look like, and you can decide upon what are the how you can divide that prototype into widgets. So in Flutter, how to build a simple layout like hello world. Okay, so simply choose a single child layout. That is because we only need to show hello world, and hello world is just a text, and that is single child. We don't have any other item on the screen. So simply choose, and the child widget needs to be at the center of the screen, right? So here we have hello world at the center of the screen. So that makes it a good candidate to keep this hello world as a child for center widget, right? So all we need to do is choose the right widget. So in our case, we will choose the center widget, and you write your child text widget with hello world, simple text. And if it is not a text, an image or an icon, you can simply provide whatever it is. And in Flutter, this is all declarative language. So you are simply telling what you need, and you have a lot of less boilerplate code that you need to write compared to other platforms. Okay, so now we have put the child text inside a center widget. Okay, center is a single child layout, and we get this result when you run that code. But you have to place this center widget inside a body of another widget. So here I have to tell you about some of the new things. Okay, in Flutter, everything starts with a widget, and that is the app widget. Okay, the app widget is going to occupy all the screen, and it is going to have some of the properties at the overall app. Okay, and this is the root widget. This is the root widget, and this root widget is going to contain as many widgets as possible in order to fulfill the prototype requirements. Okay, and typically we extend the my app as a stateless widget, and then we here we are returning a material app. Material app is a widget provided by material library, a Flutter library. Okay, and this library has all the material design components that we can use So if you want to use any components from the material library, you have to use material app at the top level widget. And material app provides us placeholders for a title and home. And this title will be shown, for example, in the recent apps button when you are on the mobile, on Android. On when you tap on recent screens, it will show up this title. And then we have for home, we have another widget called scaffold. This is simply a fancy name, but all it is doing is simply filling this screen. And scaffold actually provides us with a placeholder for this top app bar. As you can see here, the top app bar in a blue color with a title. Okay, so the app bar and whatever text we gave here is visible there in here. And then the body. So this part is a body. So this part is a body that is showing hello world. So why we have this material app and scaffold? As discussed, this is all to quickly build UI components based on material design. Okay, and they come with placeholders to quickly declare. For example, this app bar, it has a shadow here. It has a height, certain height. If you don't use this widget, you have to declare each one of them. You have to declare a blue, or you have to declare this app bar with a certain height. You have to add a shadow, and then you have to declare the text, and then you have to specify how the body is going to take the space. Okay, and it is providing with us all of that. And the material app, you can simply set theme, overall theme. So you can simply set what is the primary color, like here it is a blue color as a primary color and a secondary color. You can specify color themes. You can specify anything related to the overall app in here. Then we have so from here you have the body, and from here you can use any of the material widgets and to keep building the UI. Okay, so to quickly recap the layouts in Flutter, we have single child layouts and multi-child layouts. In single child layouts, some of the useful ones are container, center, and padding. And in multi-child layouts, it is a column, row, or list view. So and in order to build a simple hello world program, you can simply choose a center widget as a, and then provide a text as a child to it, and add it to the scaffold widget. Okay, and then build it. It will show the hello world program. Okay, so the next we are going to discuss more about working on the columns and rows, because these are primarily the widgets that you will be using. These are very flexible widgets in terms of grouping multiple children and positioning them. You have a lot of flexibility in terms of the space arrangement. A lot of times you have a complicated UI and you can simply use columns and rows to build it. Okay, so like for example, you need to build. So you have, your designer has given you a UI prototype as shown in here. Okay, this is a large screen. Okay, you have a lot of text and icons on the left side, and you have one large image on the right side. So how do we build this in Flutter using these multi-child widgets? Okay, so first of all, take the screen and divide it into based on the direction. Okay, so when we look at the overall screen, you can simply divide this whole thing into two parts, right? The left part and the right part with the image. So that's two children, and these two children are arranged in the horizontal direction. So which means it can be placed as two child. So part one divided into a one child, part two divided into a right part divided into another child. And these two children, we can place them inside a row widget, and because they are in a horizontal direction. And then the left side child, we can, if we look at it, it has like a lot of text one by one in vertical direction. So because they are in vertical direction and there are multiple of them, we can choose a column and we can group them. First, try to group them. So if you group them, they're like, you can see like this is the first rectangle, this is the second box, this is the third box, and this is the fourth box. So you can say, hey, we can declare a column and place them as 4 children. And then once you declare them as 4 children, and there are again, the top level is simply a text. So all we can do is simply declare a text widget and pass this text and set the right size you need for it. And the second one is also a text, so no issues. But the third one, we can see there are multiple items again. So, and looking at the grouping, we can simply say that, okay, there are 2 items in horizontal direction. So this makes it a good candidate to keep them as a row. So you can declare a row with 2 children. One is a row of stars, another is a text. These stars is again 5 items because each one is a single icon here, and because of that it is 5 icons placed one by one horizontally. So we have decided to make it as a row of 5 children. And finally we have another group of children, and when you look at them, you can see that there are the pattern is that we have these 3 items arranged horizontally, so that makes it a row. And then inside the row, each one of them has a similar structure in the vertical direction. So we can take it as a column. So we can place these in a column and declare each of them. So in the column we have 3 children. One is an icon widget, another is a text, another is a text. Okay, simply 3 of them. So looking at here, furthermore, this is how the widget tree will look like if you just simply consider this group of children. What we have here is a row containing 2 children. This is the row that I'm talking about. This row has 2 children, a row and a text. And we have placed this row inside a container. That is usually because with container we can specify padding and margin around the whole layout. So this whole row can be wrapped inside a container to give it some margin or padding, etc. So we have, and inside the row we have another row, and this row is simply containing 5 children, okay, which are icon. Each of them is an icon, and this one is a text. So this is the widget tree, and the widget tree goes on as we combine. As the widget tree will grow bigger as we combine all of the items for each of them on the screen. And this is the code that will needed to show them. So what we did is we have wrapped up them in a row widget, and each of them is an icon widget. So we simply have 5 icons declared, and we are providing it as icons.star. These are readily available in the code. You don't have to download images from the internet. Flutter provides them automatically from the library. So you can use this star, and you can even set the desired color. So we have here 3 stars with green color. So 3 of them are in green color, and 2 of them are in black color. Okay, and we have simply declared this whole block in as a variable. Okay. So now we have combined our rating row with this text here. So we have the stars coming from here. This stars is this variable here. So this variable is declared here as one of the child, and we have text view, which is representing this 170 reviews here. So we have the stars and the text, which is set inside a row, and these are using a property called space evenly, so that all the available width on the screen is evenly spaced between these two items. Okay. And similarly, if you consider the items below the ratings bar, we have, you know, three children here. And again, we place them in a container because we will be usually adding a margin to all the whole group. So whenever you need to add some padding or margin or give it some specific background color, we can place that whole group inside a container. And this container has one child, which is a row, and that row is containing three columns. So each of them are here. This is one column, this is another second column, and this is the third column. Okay, and if you look at one column, it has one icon and two text. So you can see here there is one icon and two text. So this is how it works. You know, you divide the whole UI screen, your prototype, into columns and rows. Okay, and then group them, find out if they are arranged in vertical direction or horizontal direction, and find the right layout widget and place them. Okay, widget tree is more for having a clarity of thought on how we are placing one inside another. Okay, so this is how the code looks for this part or this group of children. So as I said, we have a container and we place the whole group with a 20 pixels padding. And since container is a single child layout, it has only one row as child. And this row itself is this whole thing. Okay, this whole code block is one row, and that row has children declared here. And there are three children, three columns, and each column itself again has three children. So one icon and two text. And this is as simple as what we have seen in the widget tree. We are really declaring what we want to display on the screen, and this is the hierarchy. You can nest as much as you like, so that you can have your desired UI. So we have discussed now about how to use rows and columns and nesting the children, in nesting in one inside another. You can nest a column inside another row or a row inside a column. Okay, and why we need to use them? We have a lot of flexibility in terms of positioning the children, whereas if you use a list view or grid view, you won't have so much flexibility. Not to worry, you can combine the layouts in any way you want, and these have flexible sizing. Okay, so in terms of nesting, you should always look at your UI screen, whatever the prototype screen you are given, and decompose it into top level groups. You have to divide them into group of children, and each group of children you have to look at its direction of arrangement. Are they in horizontal or vertical direction? Based on that, you can make a decision. Okay. So now we have seen the nesting. Now let us look into how to perform like alignment and sizing, and how to fill space or even compact the space. Okay, for the multi-child layouts, row and columns, both of them come with two reference axes. These are for row, the main axis is in the horizontal direction, which is the main attribute of a row because the children are in the horizontal direction, and cross axis is the opposite thing, which is vertical direction. Okay, similarly for column, whenever we say we are arranging children on the main axis, it means vertical direction, and cross axis is the opposite horizontal direction for a column. Okay, so we will know why we need these axes. So in a row, this axis is very useful to tell certain things like, so you have a row with three images here, and you want to space you want to keep even space between these three images. So this is the whole screen width, and you want to fill these three children, but you want to have equal space between them. For that, you don't need to calculate what is the whole width and then divide and then take the size of each image and what you want to give, and then how much space you want to put. You don't have to do all that. You can simply set this attribute and say that space evenly and provide your children, and the row will take care of doing the arrangement. So there are like 6 options, as space evenly is just one of them. So you can have the children arranged at the center. Okay, here each colored block is a child. Okay, you can think of each colored block as a different child widget. It can be an image, or it can be a text, or it can be something else. Okay, you can combine different children, and you can also have same type of children. It doesn't matter, but this is more about how you want to group them and how you want to distribute the space around them. Okay, sometimes, so let us say this is all the available space. This gray colored block is the all available space for you for our row widget. Okay, so this row widget is given this space constraint by its parent usually. So you have this much of space only, and you want to tell, okay, simply place the children at the center. You're going to use the center option, and you want to keep the children grouped together, but start from the beginning. Similarly, put the children arranged at the end of the box, end of the available space. We have seen space evenly. Space around is very similar to space evenly, except it will put a little space at the beginning, a little space at the end, and then remaining space will be distributed with the children depending on the number of children here. And then this is also another similar option. It won't put any place at the beginning or at the end, but it will put space between the children. Okay, and actually all these options you can say are available for a column as well on its main axis. So before we go for a column main axis, we have cross-axis alignment options on a row as well. So this cross-axis is in the vertical direction, right? So in the vertical direction, we have some space on top of the children and below the children. So the cross-axis options will simply is all about adjusting this space in the vertical direction. So you say cross-axis. You say that at the start the children are simply pushed to the beginning of the row at the top, and the end will be vertically bottom, and stretch will occupy the whole height of the row. Okay. So in column also we have similar options. We have main axis for the column in the vertical direction, and you can say space evenly, and images will be spaced evenly inside a column. So we have all these 6 options again in the vertical direction. If you were to just rotate them, it will become a row, and we have discussed all the same options. So in center, so this is the main axis. So you can arrange the children at the center or to the top or to the end, or space them evenly, or just give some space around them, or put some space between. So the only difference between these last two is that the space at the beginning and the ending. Okay, and the space in the middle varies based on the number of children present in your layout. And similarly, we have cross-axis alignment options for a column. So this is in the opposite direction, which is a horizontal direction. So here you can have children in the you can arrange this space. So you want to have the children on the cross-axis in the horizontal direction at the beginning, at the end, or to fill the whole width. Okay, these are the options. And sometimes you might have bigger widgets that won't fit the space. It might be going out of the screen. In Flutter, if something goes out of the screen on the device screen, you will see these black and yellow stripes. That means that your children are overflowing the screen size. In such cases, you can use an expanded widget. You can simply wrap your images inside a expanded widget. Expanded widget will take all the available space and divide it equally among the children. And you can provide a flex factor for each of the expanded to proportionally give the size. By default, it will give equal space. The flex value will be 1 for each of the widget. But if you say expanded with flex value 2 for the first child and flex value 1 for the remaining 2, then the first one will be twice as bigger as the other 2. Okay, so this is what you can see here. So you say flex value 2 for the middle child here, and it will become twice as big as the other 2 children. Sometimes you want to tightly put the children at the center. You don't want to distribute the space. Okay, in such a case, you can use the main axis size property, and you say you want to have a minimum size. You have only two options here: main axis size with min and max properties. You can specify either of them. So we are nearly coming to the end of how to use the row and column, and we will look into some code as well. So we have discussed how to align the children along the main axis and along the cross axis, and how to perform sizing inside using an expanded widget. Okay, so usually these are the options you have: center, start, and end, and space around, space between, space evenly. This is all about spacing the children. Okay, easy. Okay, before we look into common layout widgets, let's take a quick look at a column and row in a code. Okay, uh, so let me open my example code. Okay, so here we have our main.dot file, which is calling the run app with my app widget at the top, which is simply calling the material app widget, and it in turn is a building scaffold widget, which builds app bar, center. Okay, so I want to take you through quickly about how a row or a column works. So let me run this code on the emulator so that you can see what it is actually doing. So let me show minimized version. Our widget is building a row with 3 children, and these 3 children, we simply have 3 text views. Okay, and we are telling it to space evenly. So sorry, I have run a different program here. I need to choose this main program because it was running a different main one. I was running a wrong target. Okay, I have several examples here. So now we will see a row coming up. Hey, here we go. So here we have a row with 3 text views, and these text views are arranged with equal spacing. You can see that we have equal space between each of the children. Okay, so we can play around with these options. Okay, we want to say, let's say we want to space them at the center, and then execute a command S. We have the Flutter hot reload immediately reflecting, changing the children centered. Okay, now they are all in the center. Okay, and similarly, if you say start, the children, this group of children will move to the beginning. Command save, so they have moved to the beginning. And you say end, command S, they go to the end of the screen. Okay, and similarly you say space around, command S. Now you see that the space at the beginning and the ending at the end is slightly smaller than the one in the middle. That is because Flutter is just simply trying to provide you with space around. It does not care about uniform space. If you want uniform space, then you need to use space evenly option. Okay. And if you simply want just some space between the widget and not worry about space at the beginning or at the end, you can use space between. Okay, and all it is doing is this row widget is working on arranging these three children, and each of the children have simple text and they have some styling attribute. With this style you can specify the font size, font family, and the color of the text. Okay, this is a text widget. So similarly, you have the second text in red color with a bigger font size, and third text with a bigger font. Okay. Now, as you can see, this demo widget is building a row, and this demo widget itself is a child of another widget called center. And this center itself is again part of scaffold widget. Okay. And scaffold is part of the material app. You can see this tree. You can check something called Flutter Inspector here. This Flutter Inspector, you can select Open Dev. You can go to More Actions and click on Open Dev Tools. So you can see that we have my app at the top level, and then we have material app, scaffold, center, and our demo widget with the row as a child and with text. Okay. You can also see that same tree inside here when Flutter Inspector starts showing you. Okay, so I mean, column works in the same way as a row. You can simply change the row with a column, and I do a save, and everything will be arranged in the column wise. And you can play around with the same options with column as well, so you know how it works now. Okay, so depending on your UI requirements, you can use these multi-child layouts. Okay, so now we have seen how to use a row and column. Let's see what I mean. You are not going to have the whole UI simply with a row and a column, right? You have to have more. Sometimes you are going to show an infinite number of children. For example, you want to show a list of restaurants. You will need to have a. You cannot show them with a column or row because these are fixed size, and they can't go out of the screen. Their size is within the limits of the whole screen height and width. So in such cases, you can use a list view or grid view which provide inbuilt scrolling. So here actually, so some of the standard widgets are container, grid view, list view, and a stack. So we have already discussed container, which has multiple properties, and there are material widgets which make our life easier. Card and list style. Card provides you with the default material card with a shadow and some elevation, and list style is as a utility widget. You can simply specify a couple of text and an image as a child in a list view. Okay, so container, you can, if this is your content, you can provide padding inside around the content, and you can provide a border as well. You can do a border decoration. You can change. You can have a background color, and finally you can have a margin. Okay, with grid view, this is a scrollable widget. When you have a large number of children, you can have them scrolling vertically, and whenever you need like multiple columns, you can go for a grid view. Otherwise, you can use a list view. If you only have a single column of vertical list or horizontal list, you can simply use a list view. But if it needs to be multiple columns, then you can go for a grid view. And there are two ways you can implement a grid view. You can use a grid view.count, or you can use a grid view.extend. Grid view.count, this count is simply about telling the number of columns you want on the screen. So here in this case, it is having 2 as count. And grid view.extend is about, okay, I say that I will give a maximum width for each tile on here, and then let the grid view decide number of columns. I will say, okay, this is, let's say I give it 150 pixels as maximum width for each tile, and if there is like 300 pixels width, then grid view will divide it into two columns. So grid view.extend, you simply specify, okay, the maximum width you want to provide for each child with this property, with this property, and then you can specify some padding around the whole grid view and also spacing between the children. So you can see some spacing between the each column. That's coming from this main axis spacing and cross axis spacing. Finally, you provide the list of children you want to show in a grid view. Okay, so inside a grid view, we have here in this example, it is simply taking a list of images, and each image is having with a number. It is like picture 1, pick 1, pick 2, pick 3. The name will change depending on the I value. Okay, the count we are passing is 30. Okay, I mean, don't worry about this code. The main idea here is how you can construct a grid, and you can provide the children in different manner. You don't. This is simply to show an example of how we can provide children. Similarly, with a list view, you can provide a single column, and it provides you inbuilt scrolling. So it is very useful in most of the situations, because most of the apps, you really need something scrolling vertically or horizontally, because you can never fit everything inside the screen we have. So here in the list view, we are simply providing a number of children, and each child is implemented as a tile. Okay, as you can see, for each child we are calling this method called tile, and this method tile is simply returning a list tile. So all of them are simply returning a list tile, and they are all in here. Okay, whenever you need to place children one on top of each other, you can use a stack. So here you have an image, okay, an image with a circle avatar, and then you want to place this small container box here, this small container box, and that is having a black color. This is a semi-transparent black color. That 45 black 45 number indicates the transparency level. So you can see that you can still see something behind this text. Okay, so you simply have two children here. One is this image itself, and another is this container. And this container itself is containing text as a child. And since this is a stack, one item is placed on top of another. Okay. So card provides us with elevation. In order to implement a card like those shown in these pictures, we can simply wrap it in a card widget simply by calling card. And then in the card child itself can be anything. It can be a column, it can be a row, it can be anything. The thing it provides is it provides you with round corners and properties to properties to adjust how much roundedness you want at the corners, and elevation, so that there is a shadow coming up. You can adjust the shadow as well. Okay, so this card here is simply using a column with the list tiles. So there are 3 list tiles here in this column. This is the first tile, this is second tile, third tile, and all 3 of them are placed inside a card. Okay, so we have already gone through list style, but in detail, in specifically list style provides ready-made placeholders. So like you need an icon, you need a title and a subtitle. So you can simply specify what's your title value, what's your subtitle as text views, text widget, and then provide an icon here. You can also provide a trailing icon that can come at the end. Okay. So now we have gone through all the common layout widgets we use in Flutter. I mean, like literally, like with these widgets, you can build any kind of prototype UI. Okay, you have column and row, and then you have for scrolling behavior, you have a list view and grid view. And when you need to place things one top of another, you can use a stack. Okay, and when you need to build a specific layout, a group of children, you can use and add them, put them inside a card. And you can also use a list style to quickly build a small row of children. Okay, so now we know all of the widgets. Let us go through a sample code to understand how we can use these widgets. Okay. So here, this app is going to demonstrate using a grid view and how we can provide, how we can also construct the children. Okay. Since we have another 10 minutes, I'm going to show you how you can use these widgets briefly. Okay, so here again, our code starts with the main dot dot, and main dot dot simply does call the run app method, and this starts building our widget tree. So our widget tree starts with our root widget my app, which simply builds the material app, and I have set a themed color. So this deep purple is the primary color shade. This color shade is going to be used throughout the app as a primary colors, primary color. Okay, and then we have a scaffold, and then I have a center, and it is showing a grid. Let's see how it looks like on an emulator. Let me place the emulator here. Okay, now so let it build this app, but until then you can observe that all we have is we have started with a code that is simply containing our top level widget my app, which is building a material app with scaffold, and it is simply having one single child, a center widget. Okay, this center widget is gonna take a grid view, and this grid view is placed in the center of the screen. So what we have here is we have this whole screen available to us, and this whole screen size is taken up by the material app and the scaffold, and the scaffold has used some of the space for providing the app bar, and it provided the rest of the space for the body. Okay, So this body itself is again is given with a center widget. So the center widget by default it occupies the whole space. If we have more margin and padding around the grid, then we will understand that this is how this center widget is working. But we'll get to know about it anyway. I will show you. So let's look into what's happening in the grid itself. So going to the grid, I jumped into the grid, and this grid view is present in this home page dot dot. So this grid view is again is building a scaffold with an app bar, and this is showing our title, Tamil Nadu tour, and we are using the gridview.extend as the constructor, which provides us which I have specified as 200 as the max width. So each tile cannot be more than 200. So it is going to use that as a limit and calculate. So we have this total width. So we have this much of width here, and that width is divided into two columns based on this number. If I give a smaller number, then it will it will take up, it will build more columns. And this main axis spacing is the spacing between here. If you want, you can check. I changed it to 28 and I did a Command S. So this main axis space is in the horizontal direction. So here we can see 28 pixels are adjusted. You can also see cross axis spacing. If I increase it to 28, Command S. So cross axis spacing is in the vertical direction. You can see that in the vertical direction, the cross axis has improved. Okay. So you can play around with these options to get your desired output. I'm just going to put them back and do a Command S. So once you declare the grid view to fill the body, all we need is pass the children. So what do we have? Each child is a tile. It is containing an image and two text. These two texts are arranged in a rectangle, semi-transparent black box, right? So let's look at each of the grid items. So this method here is building all the grid items by taking photos. So I have a simple method called get photos. So this is some ready-made data I have put in to quickly show you. This is all just containing a lot of images and their title and subtitle. Okay, well, this is all like a fixed data that I am passing. So you get all this photo and its metadata here, and it is this grid item is using each of the photo item to build the view here. Okay, the grid view itself, the grid item itself is containing an image, right? So we need the grid tile to have an image and also a footer. This is the rectangular box containing the title and subtitle in the footer. Okay, so the footer is a useful utility provided by grid tile widget. You can simply specify a title, subtitle, and whatever the background. So this is a semi-transparent black color here. Okay, so this is the footer, and this is the corresponding code. So you say grid tile bar and specify the color and text, title and subtitle. That's it. And similarly, then you are saying a child as image. And when we tap on the image, when we tap on this tile, we want to navigate to another screen. So that is also very simple in Flutter. You simply use a navigator.push and you specify the page you are going to take. So this is simply, you have to specify. So in Flutter, we call every screen as a root. Okay, so you are saying navigator and push a new root, which is called a detailed page. And I am providing, so if I tap on this item, I'm sending this photo data as well to that page, so that it can open up nicely and open up the page with all the children. So if we jump into detail page, and this detail page has this layout. So for this is built using again a scaffold containing an app bar. The app bar is showing our image title, and and then we have the body implemented primary as a list view. So this list view has 4 children. Okay, one is the image at the top. So this is our image. So this is the image we have at the top, and then we have the title section. Okay, and then buttons section, and then text section. So this is the title section, and then we have the button section. Okay, this is the button section, and then we have text section at the end. So we have basically divided the whole screen into a scaffold widget so that we have an app bar at the top. So you get this app bar. You are also specifying this back button here. Okay, so we have the app bar, and then inside the scaffold body, in the body we are telling it as a list view containing 4 children, an image and a group of text and a group of buttons and another text. Okay, why did we use a list view? Because we need this whole thing to be scrollable, because this text is going out of screen size. So if you put it inside a list view, it is going to scroll. If you put it in a column, it is going to show out of bounds. So that is going to cause trouble, right? You don't want that behavior. So we have the image at the top. Simply with the photo, I'm passing the location of the image, and then yes, I'm setting it certain height and width. And then we have title section. Let's look into title section. So the title section itself has is built as a row. Okay, so this title section is built as a row, and it is again containing 2 children. Okay, one is the first child. The first child is placed as an expanded widget so that it can occupy more space than the second child. Okay, so here this is the row, and this is the first child, and this is the second child. Okay, so the second child is here, the icon with the text. Sorry, we have 3 children, right? Icon itself is another child, and text is another child in the row. Okay, the first one itself, the first child itself is again, we have 2 text views, one below another, so that can be a column. So we can group that as a column and show those 2 text boxes here. And this text is placed inside a container to show some padding around it. Okay, you can actually see also, like, enable this debug paint option here on the visual inspector. Let me show you again. So you go to visual inspector here, tap on it, and select this debug paint option, and that will highlight how each layout is working. Okay, how they are grouped and the spacing arrangement. You can see the list view direction was scrolling vertically downwards. This is another group. This is another group. Okay, so we have our title and a star icon here and another text here. Okay, that is all done. And then we have buttons section. This buttons section is wrapped in a container with which is containing a row. Okay, because we have this as this row has 3 children here, and each child itself is a column, right? We can, because they have 2 items in the vertical direction, we can keep them as a column. So you can see that those are built as a column. So we have used a function. We are calling a method called build button column, because these 3 have same structure, just the variables are changing. We have icons are changing and the text are changing, and we need to set a color to look it nicely. So here I am passing the primary color from the theme. So that okay. So this color is coming from the theme itself. Okay, you can simply use this code called theme.color, primary color, to get your color you declared in the beginning. Okay, so there you go. You have these buttons, and this column itself is built again uh, as simply two text here. This is a column with one icon and one text. Okay, so you got one icon and another text, and we are wrapping it with some margin. That is why it is inside a container. Okay, I think we are nearly there. So we have our buttons as a column, and then we have the text at the bottom, this large text provided. This is provided in the text section. We have this simple single text widget that is taking this whole text that is shown here. Okay, and the soft wrap here will simply wrap it with nicely. Okay, so this should give you some glimpse of how you can use a scrollable multi-child widget like a list view, and flexible multi-child layouts like a column and a row. Okay, and how to use the navigation, how to move from one screen to another. Okay, and all now this is ready to run on all the three platforms. You simply choose your target devices. You can run it on your Chrome browser as well, and you can run this program on your iOS as well and test it how it looks like. So these are going to take time as we are running it for the first time, and then once you have run the build for the first time, it installs the app. From then onwards, we should be able to use the hot reload and hot restart to quickly update the changes. So the iOS is still haven't updated, it's still taking time. Resize this. So let's see what's happening with iOS. Oh, it just lost connection. I'm just running it again. Okay, so as you can see, like you can build a nice beautiful UI really quick. We have simply tried to take the prototype and divide it into groups of children, and map it to the right widget and declare those widgets in the UI, and we have very easy navigator that takes us from one screen to another. Okay, and then we have simulator and emulator and Chrome browser to test all the three platforms. So now the iOS build is also ready, and it has come up with our UI. So all we have is this grid view showing the list of children, and you tap on them and you get this nice expanded view. Okay, so I hope that was useful. And this is what I targeted to show, although I ran out of time. Okay, slightly, we crossed the time slightly, that's fine, I guess. So I'm really glad that we had this session today, because I'm very excited about developing on Flutter, and I want to see more people becoming app developers, because this is an exciting field. Whether you are aware or not, we are going to develop software interfaces forever. There is no end to it. And of course, it is getting easier and easier. If you are working on native Android or native iOS, it is more complicated than working on Flutter. So if you are starting newly into app development, my suggestion is you can start on Flutter, learn Flutter, and then learn the basics of native Android and native iOS, so that you have an idea of what is going on the native side. As the time goes by, you can pick up more concepts on the native SDK as well, and then that will make you proper app developer. Because in this times the technology is rapidly changing. It is not enough to simply know one platform or one SDK. You are going to need skills across platforms. Okay, and but the good thing is we are going to learn more platforms, but these platforms are getting easier and easier. The complexity level is going down, which is a great thing. Okay, if you want to start your journey on app development, like I did way back, in around 2009, I started working on. I made a decision to become an app developer, and I started working on Android in 2009. And I'm glad that I made that decision, and it is still going on very well. The market is very good, and you are never going to run out of work in the app development field. Uh, so that comes us to a conclusion. I'm also providing training on Flutter as a full-fledged professional course. If somebody interested in becoming an app developer from scratch, I will take you in the course from the beginning, from the basics to the advanced topics, and you would also understand how the real-time tools will look like in an app development team. Okay, so if you want to start your journey as an app developer, fix your career, you can contact me at this email ID. And even if you have any queries about app development, you can reach me here. Okay. Thank you for joining the session. That is all I have for today. Have a great time, guys.